This is a video from the Exam 1 review in my linear algebra class. Let's take a look at problem 10. Let P equal the point 0, 3, 1, Q equal the point negative 4, 5, negative 1, and let R equal the point 2, 2, negative 3. These are points in R3. We're going to let the vector U equal negative 4, 2, negative 2. Let V equal the vector 6, negative 3, negative 2. And W equal the vector 2, negative 1, negative 4. Part A, we want to find 3U minus 2V plus W. And so this is what I do. I want to look at 3U. 3U is 3 times the vector negative 4, 2, negative 2. And so notice here, I take every component and multiply by 3 to arrive at the vector negative 12, 6, negative 6. 2V is 2 times the vector 6, negative 3, negative 2. And then notice when you multiply 2 times the vector 6, negative 3, negative 2, I'm going to take every component and essentially double it to arrive at the vector 12, negative 6, negative 4. And if we recall, W is the vector negative 2, 1, 4. So all we have to do now is put it together. 3U minus 2V plus W is the vector negative 12, 6, negative 6, minus the vector 12, negative 6, negative 4, plus the vector negative 2, 1, 4. And my final answer should be the vector negative 26, 13, 2. That's part A. Let's take a look at part B. In part B, I want to take the dot product of V with 3U minus W. Now, 3U is the vector negative 12, 6, negative 6. W is the vector negative 2, 1, 4. So 3U minus W is the vector negative 10, 5, negative 10, right here. So when I look at this dot product, I'm taking the dot product of V with 3U minus W. And so that's the vector 6, negative 3, negative 2, dotted with the vector negative 10, 5, negative 10. Now, when we do a dot product, right, I'm going to take 6 times negative 10 to get negative 60. I'm going to subtract negative 3 times 5. In other words, I'm going to subtract 15. And then I'm going to add negative 2 times negative 10. In other words, I'm going to add 20. And my final answer should be negative 55. That's part B. Part C. For part C, I want to take the norm of negative 4 times U plus V. And so if you notice, I look at U plus V off to the side. I want to figure out what that is first. And it turns out that U plus V ends up being the vector 2, negative 1, negative 4. So this is equal to the norm of negative 4 times 2, negative 1, negative 4, which is the norm of negative 8, 4, 16. And so then all it comes down to is taking the norm of that vector. And so this is the square root of 64, that's negative 8 squared, plus 4 squared, which is 16, plus 16 squared, which is 256. So in other words, the norm of negative 8, 4, 16 is the square root of 64 plus 16 plus 256. And so we're looking, in other words, for the length of this vector. That's the square root of 336. And when we simplify that, we should come up with 4 times the square root of 21. That's part C. Part D, we want essentially the distance between vectors U and V plus W. Now, V plus W is the vector 4, negative 2, 2. So we're going to look at D of u, which is negative 4, 2, negative 2, with the vector v plus w, which is 4, negative 2, 2, right here. Now, that's the norm of negative 4, 2, negative 2 minus the vector 4, negative 2, 2, which is the norm of the vector negative 8, 4, negative 4, which is equal to the square root of 64 plus 16 plus 16. And that's equal to the square root of 96. And the square root of 96 simplifies down to 4 times the square root of 6. And so the correct answer for D is 4 times the square root of 6. So remember, D of u v plus w is equal to the norm of the difference between u and v plus w. And that's basically what I did here to get to this line. Okay, that'll conclude this video for Exam 1 Review Problem 10. Thank you.